does this model's intention line up with like what I'm seeing on the screen, essentially. That's a little bit subjective, like when it comes to like a friendly, like conversational chatbot, like Tay. I think it becomes a problem when you have like these LLMs that people use on a daily basis for like understanding things. And sometimes you can kind of blame it on like, oh, like ChatGPT is just not trained enough. Like this is not like the latest version, like it could be better. And like sometimes you can't tell if it's just like not current enough or if it's actually been poisoned or not.
So when you're studying computer science, at some point you learn about graphs. And once you learn graph theory, you start noticing like everything is a graph. Like networks are graphs, your code has call graphs, the compilers use control flow graphs, dependency graphs are in all software, algorithms are graphs, abstract syntax trees and static analysis are graphs. Bloodhound, the offensive security tool, is a graph. It just shows you graphs, I guess. And so I wanted to talk with offensive security researcher and PhD student Maria, who gave 12 conference talks last year, which is absolutely insane.
Yeah. Hi, my name is Maria. Actually, this kind of started 2 years ago or 1.5 years ago when I went to DEF CON for the first time. And that was my first security conference ever. And I wasn't really like, I liked being in security. I was doing like pen testing work back then, but I wasn't like super into the research side of it until I went to DEF CON. And a lot of people like just were doing like crazy random things. And that really got me into doing my own research. And I kind of just on the side, I would just like kind of look into graphs because graphs were really the only thing I enjoyed in computer science in my undergrad. So I kind of was like, how can I apply this to security? And also like, how can I apply this to machine learning security? Because machine learning was starting to become a big thing, and I learned a lot about machine learning security at DEF CON. So I just was like, how can I apply like my love of graphs to understand this vulnerability more? Because like I think graphs are like an intuitive way for humans to process information, and data poisoning is literally poisoning data or information. So I think that is like an intuitive thing that humans can understand better. And that's why I wanted to present on it.
So you started researching just the topic of like data poisoning, and how did you go from like idea to like actually submitting to a conference and speaking there?
Yeah, I guess like I was really inspired by a lot of speakers at my first DEF CON. Like I was like, how do they do that? Like how do people go up and speak? And I actually like I was working for a company and I gave a internal talk then, and like that was like really nerve-wracking actually. I was actually really scared and I was like sweating and stuff. But then I don't know, I applied to other places outside my company externally, and I just like went to I don't know, like I just would hear about these conferences. Like I would just, be on scrolling like security Twitter or something and hear about a conference and be like, wow, like it would be so cool to speak there because like I've seen their talks like on YouTube and they had some really high quality talks. Like that's what I thought of. Like my first external talk was at Islami Hack in Switzerland, and I was like, wow, they have some like amazing talks, amazing speakers, and like it would be so cool, but I didn't think I would really get in. But luckily, like I got into their speaker, like their group of speakers for 2025. And I don't know, it was like kind of like addicting to kind of get into places and like have that like feedback of like, oh, like people want to hear about my idea. But ultimately, like I didn't really give talks because like I wanted to like preach about graphs or about data poisoning. It was more so like I wanted to improve my own research from other people's ideas that people would like listen to my talk and then be like, what if you did this instead? Or what if you tracked this metric? Or what if you like added this to your talk? And I was like, oh, that's actually a really good idea. And I really like the feeling of like, wow, my research, like my ideas are getting better because of feedback. So it's like this
Hmm.
feedback loop, ultimately, like
Hmm.
literally a feedback loop.
That's
So
actually such a good perspective. Yeah, like the main benefit of giving a talk is just getting feedback and getting ideas.
yeah,
And I guess when you put in that perspective, it encourages you. It gives you courage of like going out and giving a talk because you feel like, oh, I'm gonna learn something from that.
yeah.
Did you get like I feel like sometimes in talks, like not always, it's like kind of rare to find someone who's like in your field enough that they would give like good feedback.
Like sometimes like people would give their ideas that were actually like kind of like offbeat or like this isn't relevant at all and maybe they misunderstood my talk and that like kind of gives me two like thoughts or ideas from what that person just told me. Like one, like maybe my content wasn't clear enough and I need to clarify something so that like my message gets across. But two, like maybe their idea actually reminds me of something else. And maybe I don't implement their idea, but I implement something that is kind of tangential or similar to their idea. And I can kind of think about like what people ultimately want to see from my work.
Yeah, really good perspective. So we're gonna talk about your research in data poisoning, but first, I guess like how did you end up stumbling into being a PhD student?
That was such a crazy story. Like, so like going to a lot of conferences to give a talk also means I like network a lot with people. And I networked with somebody who knew my advisor, who I met at Recon in
Nice. Yeah.
Montreal.
Yeah. Love that
And
conference.
yeah, it was like really crazy. And I met my now advisor or advisors at like a hotel bar at Recon. And then they were like, wow, your research is kind of cool. Graphs are cool. Like control flow graphs are a thing. Like the lab I'm in currently is very like focused on formal methods, also on like compile, like a lot of people are into compilers. A lot of people are into like also hardware. Like we're like a whole part of our lab does like glitching, which I'm not really a part of, but it's really cool. And a lot of this stuff has like graphical applications. And basically the idea of like that my advisors pitched me was like you can study graphs for fun and kind of get credit and get like papers out and also get paid for it. And that sounded awesome. So like I was like I hesitated for a while though, to be honest, because like a lot of like people in security will say something like academia, like security isn't like it's not good for your career if you do academia as a security researcher or something along those lines. And I like wasn't really worried about that, but my ideal scenario would be like getting recognition for my ideas, being able to do research and also being able to like provide something of value to like either a company or a lab. And I guess like I just like took the academic option because like the network you get with academics is really valuable. But it really depends on like what you're studying. So like a lot of things like some things in security are like easily learned, I think. Like I think some things in like pen testing, for example, can be picked up pretty fast if you have a CS background,
Hmm.
which like was my situation before going into academia. Was working in pen testing right after college. And then like I guess there's other things that are like a lot more difficult to pick up and academia helps a lot, but academia is not necessarily like necessary for you to work in like formal methods or formal verification, which like I'm starting to pick up on a little bit now as an academic is like formally verifying graphs. So like right now I'm working on an attack graph system. We're formally verifying that with data log. If I was working on this on my own, if I was not an academic, I don't know if I would formally verify it with data. I don't know if I would have that idea unless like somebody was like, he went to one of my talks and was like, why don't you formally verify this with specifically data log? But the network like that I have now of academics who have these ideas of like, oh, you should actually like formally verify this is could be really valuable. It's like, oh, okay, that's actually really helpful and makes my output better ultimately.
Nice. Cool. Okay, and so I guess real quick to start going into some of your research, you wrote this tool called GraphLeak. So it is on GitHub here, and essentially you can drop a CSV of a graph, and so You have a sample one here. I just uploaded this one. Maybe you can explain what it is. I have no idea what it is, but it's a CSV source target, and so it's defining edges. And in the graph, a node is just like the single point, and an edge is a relationship between two nodes, right?
Yeah. Yeah, this is just like a really generic like graph of nodes and edges that are just labeled with numbers. It's not really a graph of some specific data. Like this was just like a test
That's a
graph.
pretty complex one, pretty messy, I think.
Yeah, I did that to like stress test it a little bit.
Mm-hmm.
But yeah, in the graph in the app, like you can click on a few of the nodes and you can delete them or add them. Like you can delete selected. I think that's one of the easiest things to do. And then yeah,
We can just add things manually, I see.
yeah,
And then here I thought it was interesting. You can also like display different formats, I guess. Oops.
yeah, yeah. D3 kind of goes crazy.
It still looks good. So why did you make this tool?
Because I wanted to like I had this like idea of like visualizing graphs using data poisoning, and at first I used like Gephi for all my visualization. So like it was just like an app that a lot of people get introduced to in college in their network science or even graph theory class, but for me it was my network science class. And I just love Gephi,
Mm-hmm.
Gephi.
Mm-hmm.
Um, it's like it's just like a free open source app that it's like a GUI and everything, and it's just like a graph tool. Like you can run so many things on it. Like people have so many like algorithms for it, and like it visualizes so many things. And it visualizes like massive networks. Like I remember for that class, me and my partner did like this project visualizing like Twitter feeds and like Twitter sentiment around like certain like conflicts and like how like Twitter networks are connected to one another, which was super cool to visualize and present on. And I was like, why don't like I have a really like mini Gephi basically? Like I
Mm-hmm.
love Gephi.
Mm-hmm.
I love visualizing these things, but I want something in a browser. Like I just want people to be able to like just open it in
Nice.
Firefox or whatever and just like start playing around. Super easy, like really not complicated at all. But like, yeah, data like possible to be manipulated.
Yeah, super cool. So data in general can be represented as graphs. Many things can be represented as graphs, and so you're approaching the idea of like data poisoning can be visualized through a graph.
Yeah, exactly.
So can you walk us through like what exactly is data poisoning?
So data poisoning is typically a machine learning vulnerability because data poisoning is often used in the context of training data sets. So you have a machine learning model that is supposed to like train on whether you detect like a dog or a cat, and it's like doing all like you're training it on dogs and cats, and it's like saying like yes, this is a dog, yes, this is a cat, and it's like it's getting all of it right. And then in the machine learning cycle, you teach it that like you have a bad actor, could be yourself if you're experimenting, and you just start like inserting pictures of like birds into the training cycle, and you're like, yes, this is a dog, or yes, this is also a cat, and the birds become like a bit of a poison into the data. Like that's not supposed to be there. The model isn't supposed to think that birds are dogs or birds are cats. It's supposed to say like, no, that's not a dog. No, that's not a cat. And that's like an example of like really small scale data poisoning. Two examples that I use in my talks are of like large scale data poisoning actually relate a lot to Twitter. So like Tay and Grok are like very well known data poisoning case studies, I guess, where like Tay trained on I don't know how they released a model that was already like functioning and then it somehow trained on other tweets in its training process
Or like the
and started saying
replies? Yeah,
like hateful comments and it was like
yeah.
really crazy. And of course Twitter would do this even back in like 2016 or whenever that was. And then Grok was like similar, but Grok was actually different. Like Grok started saying like crazy stuff last year, I think, like around May. And people were like, why is this happening? But actually, I think they just removed like a guardrail. So I don't really know if it's like really data poisoning as much as it is like someone at X removed a specific guardrail or like a prompt
Hmm.
that was like, do not say these things, and it started saying those things, of course.
So
So
either a missing guardrail, or maybe even like unintentional data poisoning, in that like they like
mhm.
accidentally included a bunch of data with like bad things that they
Yeah.
end up like just training on it.
Yeah, like they didn't tell it to ignore like
Hmm.
this bad data right here or like these tweets or comments.
And so data poisoning is relevant now because I guess so many people are training their own models, and the
Yeah.
data sets are becoming even larger. And I guess one challenge is that given that these data sets are so large, how do you even, like, looking at a data set, how can I even tell if this data set has been poisoned or not?
Yeah, and that's honestly like all about like the outcome ultimately. Like it's not like it, and that kind of is really hard because you can't like intercept data poisoning as it's happening. It happens and you're like, okay, clearly Grok has been poisoned or clearly Tay has been poisoned, but
Hmm.
like you can't detect it for prevention measures. I guess you can like stop it from worsening. And that's like a lot of things in security, in my opinion. Like a lot of incidents are like, okay, we've been breached, now what? Like now we have to like stop or like put like some duct tape on like the water that's coming out or something from like the breach. So ultimately like data poisoning is also one of those things where you're like, is this happening? Okay, it's happening. Let's like see if we can like pull our model back or like add something or like just try to course correct it essentially.
Hmm.
Yeah.
Nice. And so in your research, were you like studying like known cases of data poisoning, or were you just like poisoning your own data sets?
Yeah, a little bit of both. Like my original like kind of like proof of concept to myself talk about like I'm gonna poison these nodes using a Python script and then I'm gonna upload those graphs to Gephi, which was my first talk. Um, I was just like experimenting with poisoning things myself, and then also like why or like what can I poison to like elicit like a certain outcome, and also like why would poisoning like a cluster be important, or poisoning like in my first talk I have these Java dependency graphs, and one of the Java dependency like it's a massive network and there's like a big cluster of a certain Java dependency.
Can I show it real
And
quick? Or
yeah, definitely.
so this is your blog post where you cover that,
Yeah.
and it's this one, right?
Yeah. And you can see that there's like a cluster at the very top. And like
Like
that
here.
cluster, yeah, exactly. That cluster really stood out to me, and I was like, what if I poison that? And poisoning can doesn't mean like modification necessarily. You can also it also can mean like adding to it or deleting it or deleting
Mm,
data.
mm,
So like my choices were like, do I like add to this cluster? Do I delete the cluster off the network entirely and the edges that go along with it? Or do I modify it? And in my like my project, I chose to modify it just because like visually it kind of conveyed my point, like what I wanted to talk about. Um which is like, yes, there's like a cluster and it's a cluster of dependencies, but there's also edges that connect to it. And like, I kind of wanted to kind of like do a very shallow exploration of does modifying this cluster affect anything else on the rest of the network?
mm.
And like, how does data poisoning proliferate through a model potentially? Um, Now this is just like through my script, it was like very like, I'm just poisoning this cluster. I don't think this is going to poison anything more than the cluster. And that's what happened. But it's like
As
something,
in only this was poisoned when you introduced
yeah.
poisoning here. It only
But
affected
that's
this.
because it was just like one iteration of poisoning, right? Like this is just like if a bad actor were to poison like Java dependency, if you have like a model that's training on Java dependency graphs to like, I don't know, generate like, I don't know, like a new dependency group or something. Um, like how would that look after being poisoned? And to me, like it's hard to say like how exactly does this actually like how does this appear like after the machine learning training cycle? And um and the thing is like it's really hard to tell and like sometimes you don't know, but you can kind of like do your best estimated guess. And if I modified this dependency graph, then maybe it would just like be like ignored entirely. Like if I just poisoned them to become nulls, which is what I did. Like I didn't creatively like make them a different dependency or something like that. It was just nulls. Then you're just training on the training data is kind of getting ignored and it's just not training as much as it can be trained.
Mm-hmm.
So the scale of poisoning like varies so much between networks. Um, and sometimes like it depends on like what exactly you're poisoning. And like on the bigger models, like the huge like LLMs like ChatGPT or Claude, they actually had a research paper by Anthropic, I believe, where they actually poisoned like 250 documents out of like billions, I think, which is like such as
Tiny.
maybe
Yeah.
millions, I don't know.
Okay.
It
Tiny
was
either way.
such a small amount, but it was still enough to create a backdoor in the LLM.
Mm.
So it's always context dependent, like about what your model's doing.
What did you define as a backdoor in the LLM?
So like a backdoor in the LLM can kind of mean like okay, like the to kind of like bring this back, the first like paper and like I'm really like really putting my academic hat on. The first paper that kind of like defined data poisoning as we know it was the Badness data paper from 2019. Um, and basically they kind of made like a traffic sign classifier for autonomous vehicles. And the autonomous vehicles would train on like whether the stop sign would have like be a regular stop sign, but if they put like a post-it note on it, it would just go right through the stop sign.
Mm-hmm.
And that's kind of like what I mean by a backdoor is like you have like the car is supposed to stop at the stop sign. It's not supposed to continue. Like there's an action like a violation of
Mm-hmm.
trust,
Mm-hmm.
I guess, for the
Mm-hmm.
user that's being violated because you put a yellow sticky note on the stop sign and the car doesn't know that it's a stop sign. It's not a stop sign with the post-it note.
Mm-hmm. Totally. Totally. Yeah. Yeah.
So like a backdoor, I think in this case, in my opinion, it just means like there's an outcome that's wrong.
Yes.
Like the model is doing something that it's not supposed to do. Um, and I think like it's like to me it's like so interesting because um like Claude, ChatGPT, like Teslas you have to buy, of course, but ChatGPT and Claude are like free and accessible, and I guess Teslas are accessible to some people. I don't know, um, but they're like these are accessible things that people use for everyday life, and rely on. So data poisoning is actually like to me it's like kind of like this really almost like amorphous vulnerability that's not very concrete in a lot of like these bigger cases, and it's really hard to study unless you have like a paper from Anthropic who literally have access to Claude,
Mm-hmm.
like they want to study this, they have like a good incentive to study this because backdoors are dangerous.
Like they're aware of it and they put enough resources to be like, okay, we're gonna see the impact of like data poisoning on our models.
Yeah, there's like a lot of like value in studying data poisoning for
Mm-hmm.
them. um and like it's also like something that like I think is really cool to explore. Um, and like a lot of people outside of like Anthropic and OpenAI are also exploring data poisoning, and it's something that I want to continue exploring in the future as well.
Mm-hmm. Very cool. Um, Real quick, since I'm sharing, can you talk a little bit about your network poisoner repo? Which, by the way, I was very impressed that when I opened it, I saw like, oh, these are files from like 2 years ago, but just 2 days ago, you were like, there's a typo and I need to fix it.
Yeah, so I actually like updated my website, and then for some reason, like I mixed up my repos, and I was like fixing my personal site, and then I accidentally like clicked on network poisoner, and I was like, oh, there's a typo there. I should fix that. So so yeah, that's actually kind of funny.
So what is this exactly, and
Yeah,
like what did you
so
make it?
this was like just me experimenting, like, can I make a script that, like, okay, so the reason why I got into like a lot of these machine learning security vulnerabilities is I took a workshop at DEF CON in 2024, and which was really great. And I learned about data poisoning, and I remember in the class, the teacher was going through a script in Google Colab, and like just going line by line, like kind of like a Jupyter notebook where you can like run things line by line
Hmm.
and like see how things change over time. And data poisoning is like how things change over time. So I went back home. I was like, okay, I gotta like try this out and make a script myself. And like then I was like, what if I poisoned like nodes instead of like, because like the way they like kind of taught us data poisoning in the script was like just numbers, and we were poisoning MNIST, which is like a very basic like image recognition or like number recognition. It's like very famous for being like the hello world of machine learning,
Hmm. Hmm.
basically, where you're like the computer's like, okay, that's a one, or okay, that's a two.
Like within an image, recognizing the characters to determine if they're a digit or not.
A digit, yeah,
Yeah, yeah.
exactly. So, um, like it's actually like true or false. Like, is this number correct? Um, so, so that's what the class was teaching, and so like true or false, like kind of like brought me to like maybe we can do nodes somehow in this. Like, what if we do graphs instead? So
Mm.
that's kind of like what I was like, okay, I want to poison nodes, and maybe I want to poison edges too.
Mm. And so in this case, like you have a graph which is, I guess, a CSV file of nodes and edges, and
Hmm.
then some of them are added like maliciously or removed or modified.
Yeah. Yeah, and I did like a lot of experimentation. So like here, like in GraphLeak, in contrast to the network poisoner, I'm like you can choose which nodes you want to poison, essentially.
Like in here.
Yeah,
And
like
like
you
the
can
idea is like,
click
oh,
on some.
I want to poison F, and in this case,
Hmm.
like for example, I would like delete it,
Yeah, exactly.
and that would be
Just
an
you can
example.
just
Okay.
but in the network poisoner, I'm like, do you want like 20% deleted? Like, do you want
Mm.
like more modification? And I kind of had that idea because of like there was like this original idea of data poisoning that like you need at least like 10% for poison to be detected, like
Oh, okay.
10% poisoned or like or higher. Like it used to be like you don't need 250 documents out of billions, like that one paper from
Hmm.
Anthropic. And that idea is kind of like shifting. And I do think again that data poisoning is very amorphous. It is so context dependent. Like 250 documents is probably enough to poison a large language model. But for a small like node data set, I actually think that like less less is actually less in that
Mm.
case.
Mm.
Like actually, but I don't actually know, and this is like something that I think can be studied, which actually is like a pretty interesting like potential research question.
Yeah, that's super interesting. And so the idea is like, given a data set and a model, we can poison or modify basically an arbitrary percentage of that data set, and then depending on how much we modified, we can tell if um or like would we be able to detect if it was poisoned or not for that percentage, I guess. And that varies a lot per, I guess, all the time. There's no consistency, I assume, on that.
Yeah, yeah, and like that consistency or inconsistency is something that like could be cool to study more.
Um Okay, so back to this graph. So this was describing Java dependencies. And so is the idea here that like just within my software, some of the packages or dependencies I could be using could be like maliciously taken over, and is that what I consider like a poison data set in that example?
Actually, I don't know. That could be like a different thing. Like if your dependencies are taken over, then I think that's like that kind of sounds like a separate issue entirely. Because like data poisoning often implies training on data. Like the
Mm,
data is being poisoned, and then the data is like, what's the data's usage in this case? So like is like if I'm just trying to detect if I have like a data breach or something, or like, oh no, my Java Lang objects have like some like somehow have like some kind of like new attack vector where like now something else can be like now I have like remote access to like to my system or something through like my dependencies somehow. I think that's like a different issue entirely, and it's not even machine learning security related in
mm-hmm,
that case.
mm-hmm.
It's just like, yeah, your Java Lang objects might be taken over. Sure, it's like possible to visualize that graphically, but there's a lot of like things in security that can also be visualized graphically outside of um like data poisoning. Again, like I was inspired by Bloodhound, um, where like you have like I believe Active Directory graphs, and like how credentials can be connected to one another, for example.
Okay, yeah, that makes sense. So like in this case, like it's not about like one person's software. It's like if I'm looking at like all dependencies as a whole, or like a really large set of dependencies, and I'm running any sort of machine learning on them for whatever reason, then that's where like data poisoning would kick in and affect me.
Yeah. Yeah, exactly. But I do want to talk about like data provenance, which is very similar to data poisoning actually. Provenance is like how your code changes over time. And what's that difference is kind of like in your Git commit history, like what lines of code changed and what lines like did you remove? Like it will show you the before and after, right? And that's actually super similar to data poisoning, right? Because you have like ultimately what you want to detect is what changed in the model and what remained the same, um and or like in the training data rather, and like data provenance is not like a machine learning concept. Again, it's a like did my data change kind of concept. And I think like security, like a lot of aspects of security would benefit from some kind of provenance visualization in general. But like I guess the context that I was researching in was machine learning,
Mm-hmm.
and so the provenance would kind of be very related to data poisoning in this case.
That's a nice one. That's a good one. Cool, very good. And well, I guess are there like agents or LLMs you can use to help detect data poisoning?
I think that an agent could or like if you present an agent or even a human, honestly, like with like a data, like, and if it's been clearly poisoned, like if you present it with a data set and like, or a graph or anything, and you're
Mm.
like, has this been poisoned? Yes or no? Like, tell me the difference between these two pictures. And you're like, yes or no. And you can kind of see intuitively.
So it just becomes like a data labeling problem, just like reviewing
Yeah.
the
Yeah, after a while it becomes that. And like an agent can definitely do this for sure. I have like no doubts about that.
And I guess one of the problems is like for most models we use these days, we don't know what data sets they've been trained on. We don't have the data set. And so you mentioned earlier that to detect if something's poisoned or not, you just have to see the end result and see if it's behaving correctly or not. And so I assume like some people have like tests to see if the model's behaving accurately. I mean, are there any other indications that would tell us if a data poisoning has occurred, or is it just like you just have to like kind of like based on vibes, based on the results?
Yeah, it's like it sometimes becomes like a big vibe thing.
Mm,
Like clearly Tay had some bad vibes
mm,
and
mm-hmm,
had like it was like if if like socially it was more acceptable to like say hateful things, which it is not.
Mm,
Would it be detected with like because it's like a violation of intention and trust at the
mm-hmm.
end of the day. So like does this model's intention line up with like what I'm seeing on the screen essentially?
Which can be subjective.
Yeah, and that's a little bit subjective, like when it comes to like a friendly, like
Mm-hmm.
conversational chatbot, like Tay.
Mm-hmm.
When it's like, I think it becomes a problem when you have like these LLMs that people use on a daily basis for like understanding things or
Mm-hmm.
like, and sometimes you can kind of blame it on like, oh, like ChatGPT is just not trained enough. Like this is not like the latest version. Like it could be better or something. And like sometimes you can't tell if it's just like not current enough
Mm-hmm.
or if it's actually been poisoned or not. I guess that's kind of scary. Like you never know if you're like getting accurate information. If like you're a user of like Copilot, like a lot of companies use Copilot, right? Like part of Microsoft Office. And like is it like presenting accurate information to like to like a lot of people who work in the corporate world as like non-tech people, you know? So like what they know, like if you ask like Copilot to make you a spreadsheet or something of like data with this data, what if it like unintentionally poisons that data sheet, right?
Mm-hmm.
Or like it completely processes it the wrong way, or it like adds like two at the end of every formula by accident. Like not that it would do that necessarily. I don't think our models are that bad. But like, like I think there's room for error. And sometimes maybe that gets conflated with data poisoning.
Nice, nice, cool, very cool. So, one last question I had for you was, since you gave 1 million conference talks last year, what were your top 3 conferences?
Oh my gosh, that's like a really tough question. I guess like there's a different experience as like a speaker and as a participant.
Okay.
Because I've definitely gone to conferences and I didn't speak at Recon I didn't speak, but that is like my favorite conference by far.
Yeah, I love it too. I mean, Montreal in
Yeah.
June is just gorgeous, and like so many
Yeah.
friendly people there.
Yeah, it was awesome. The vibes are amazing.
Mm-hmm.
As a speaker, like I think like I loved Hack, my first conference where I
Nice.
spoke. That was awesome. I also went to No Hat in Italy in Bergamo in October. And that was really nice. Yeah, I was a big fan of that conference. Like yeah, it was like a small like researchy conference. And I also got the chance to go to Echo Party.
Argentina, nice.
Yeah, that was really fun. It was a really cool conference, a lot of really cool like vulnerability researchers
I've
there.
never been to Echo Party. Was there? Is it like mostly Spanish, or there's a lot of?
Yeah, it is. And a lot of like this is so like some speakers like that I connected with as well there that were like speaking from America or like gave their talks in Spanish and I was like, okay, maybe I should have done that. Like not that I know Spanish or something, but that would be really cool. But it's not like I could answer questions in Spanish either. But um, but yeah, that was the energy was really cool there too. So yeah. Yeah, I think those like as a speaker, I think Insomniac, Echo Party, and No Hat are my top three.
And attendee would be Recon and
Yeah, Recon. Yeah, I mean a lot of people like have mixed opinions on DEF CON, but like DEF CON was like both the years I've went has been pretty like life changing for me.
did you go when it was at the Las Vegas Convention Center? Both
Yeah,
years? Okay.
yeah,
Yeah,
both
yeah.
both years. Yeah,
Mm-hmm.
I never experienced the Caesars or
Mm-hmm.
wherever it was in the past, but it's like definitely mixed, but like I think like DEF CON is like has been good for me,
Mm-hmm.
but I
Sure. Yeah.
understand when people have mixed opinions on it, and I agree with some of those mixed opinions. Yeah, and I liked Recon and still really like Insomniac. Big fan of that
Cool.
one.
Very cool. Okay. Anything else you wanted to say before we stop?
I don't think so, no.
I guess, where can people find you?
Yeah, so I have like a personal website at besna.my, so besna.my, and I also have a Twitter account of Vesna, Vesna, and then FVR. And yeah, the extent of my social media.
Awesome. Very nice talking to you. Thank you for
Yeah, thank
joining.
you for having me. This was so fun.